This section, section 2.1, again, is more vocab-based than hard math stuff, okay? We're talking about relations and functions. So we're going to look at graphing functions. I mean, very basic here, a little bit of graphing stuff. And identifying whether something is a function or is not. How many of you have heard the word function? You might not know what it is, but you've heard it in math. Okay. All right, good. Anybody know what it is? Okay. Conjunctions, not functions. All right, guys. What we have up here is what we call a function machine. Okay, it's just trying to get your brains thinking of what a function is. To me, this is the easiest way to remember what it is. So a function machine, or a function, it's going to be consistent. Okay, so like if I take a number, let's say 15, and I'm going to plug this number into my machine, it's going to do something to it, and I'm going to get a different number back. Thank you. Thank you. Thank you. Your page won't do that, no. So what happened? I put a 15 in and I got 30. What multiplied by 2, what else could it have done? Could have added 15, we're not really sure yet. So if I put in a 22, should be a 44? It's 44. It worked. Okay, all right, turned into a 44. So what is my machine doing to these numbers? It's multiplying by 2. Oh, we're not going to even try that, Trey. We don't want 2 of you. All right, so if I put in a 4, what should I get? Got to do something here, right? There's the 8. Yeah. All right, 42 should become 84. It worked. I'm letting the machine work. All right. If I put in a 12, should get 24. Let's let the machine work on it a little bit. It's more fun that way. I got 24. So are you seeing how this function machine works, right? You're consistently, it's always doing the same type of thing to a number, right? So if I put in 100, what should I get? Okay. You can hear it working, right? It's working. What about 25? Should become 50? Oh, oh, oh. What happened? It's broken. Okay. So what I'm just established by doing this is this number makes it not a function. My machine is broken. Okay. Can I put it back? Let's see if we can undo this. Okay. We're back. Yeah, it came back. Brought me a 25 back. All right. So a function machine, I just want you to kind of get this idea in your head, though. Okay. When I'm doing a function machine, it was multiplying by 2 on all these numbers, right? Putting it in, multiply by 2. It was nice and consistent. My machine was working. I put that 25 in. It should have given me a 50, and it didn't. So if your machine's broken, it's not a function. Okay. All right. So kind of keep that machine idea in your head as we go on here. No. Nice try. All right. So kind of talking a bit, we're kind of getting into the function stuff here, but we need to talk about relationships between numbers. It's a set of inputs and output values. So I took a number and I put it in the machine. That was my input. And then the number I got out was my output. Makes sense, right? In and out, input and output. So we can kind of write a relationship with these. We can write it in 4 different ways. You've probably used at least 3 of these ways before. Ordered pairs, right? Now, obviously, I'm not using the same numbers I had from my machine, but we could have. Right? But the number I put in, and then there's the number I got back out. We'll just write it. That's your x, that's your y. Right? Ordered pairs. Hold this thought on this one for a minute. You can write as an xy table, kind of like an ordered pair, but in a table form. Or you can graph them, meaning you're actually just plotting the ordered pairs. All right, so you've probably seen those 3. The one you might not have seen before is a mapping diagram. It takes your numbers. All right, here's your x values, your inputs, here's your y's or your outputs, and it draws an arrow to kind of show them. All right, so looking at this, this one I love the best because it's real easy to see if something's a function or not. Think about plugging things into my machine. If I went from -3 to 4, okay, I put in a 3, it gave me a -1. I put in a 4, give me -1. I put in a 4 again. Wait a minute. If I put in a 4 and I get a -1, and I put in a 4 again, I should get a -1. All right, so back to this part with the whole mapping diagram. So are we seeing how the machine is broken and it's not a function? All right, if I put in a 4 and I get a -1, then I put in a 4 and I get a 3, the machine's not good. I shouldn't be consistent when it's doing it. What? Yeah, this is all using the same data, but you're right. None of these are functions. Yeah. All right, so here's a little story problem-ish, kind of. All right, so the monthly average water temperature of the Gulf of Mexico and Key West, Florida varies during the year. In January, the average water temperature is 69 degrees Fahrenheit. February is 70, March 75, April 78. How can you represent this relation in 4 different ways? Well, we just talked about the 4 different ways, right? Ordered pairs, mapping, table values, and graph. All right, so really it's just making you practice these 4 ways. So let's kind of just go down the line. So the first one was ordered pairs. All right, so how would I organize this into an ordered pair? I have months and temperatures. Yeah, that'd be perfect. So January is which month? 1, and the temperature was 69. Then you have February, which is 2, and it was 70. March is 3. That's 75. And April, it's 4, and it's 78. So if you're thinking of the whole function machine again, these are your inputs, right? I'd put in 1, it would give me 69. I put in 2, it would give me 70. Put in 3, 75, 4, 78. Like an equation or something for that? Yeah, you could write an equation for it. Yeah. Mm-hmm. So looking at something like this, just in this one right here, is it a function? Why is it not a function? Okay, as far as the function machine, the whole pattern thing, really I'm looking at when I'm putting a number in, is it consistent? Did I ever put the number 4 in more than once? So as far as I know, I only put in a 1, a 2, a 3, a 4. Right? As far as I can tell, it's fine. Now, if I would put in a 4 again and I would get like 800, then that's not a function. Right? You're looking for that number that's been repeated. If I haven't put the number in more than once, as far as I know, it's fine. Well, it's hard to tell with that example. I probably should have made that function machine have that come out more than once. That's what I probably should have done. All right. So looking at this, no, it was a good catch. I like the way you guys are thinking, though. It's good. Okay. So the next way is a mapping diagram. So let's go with a mapping diagram. You can make your own abbreviation. All right, so mapping diagram. This is where you start with, you have 2 ovals. And when we do these, you want to make sure your numbers are in order from least to greatest. And this example is kind of set up nice because the numbers are already in order from least to greatest. All right, so in one of them, these are all my inputs. So my months are my input. So 1, 2, 3, 4. And then the other one is your output. And those would be your temperatures. So they're already in order, so it's pretty easy. 69, 70, 75, 78. And then the last part is to actually map them. This is probably the world's most boring map, because if I plug in a 1, it gives me 69, 2, 70, 3, 75, 4, 78. I don't have enough information to determine that yet. Well, and we will eventually get into things where we can do that. We'll come up with the equation for this using the graphing calculators, and we could calculate, what the next one would probably be. But we're not doing that part today. so next is a table of values. So an XY table. Right, inputs, outputs, X, Y, makes sense, ordered pairs. So pretty easy to make a table, right? You're just taking your ordered pairs and putting them in table form. So 1, 69, 2, 70, 3, 75, 4, 78. I'm sorry. And then the fourth way, graph. Probably everyone's least favorite. It's pretty easy. You're just plotting some points. Now, if I'm graphing, do I need a full X and Y axis going on here? No. Which quadrant do I need? Good. I only need quadrant 1. Right? All my numbers are positive. I don't need the other quadrants. So which is going to go across the bottom? Good. Hard stuff right there. 1, 2, 3, 4. Now, up the side, we have 69 to 78, or where our numbers are. We could just start at 69, count by ones. That's not necessarily wrong. I probably wouldn't. What? The little break. Yeah, if we're not starting at 0, we need to put that little squiggly break line right there. Just showing it's a broken graph. We're not actually starting at 0. You could do that. You want to start at 60, go by 5s? Would you have to start at 60? So I can start at 65. Yeah, we could do that. 65, 70, 75, 80. That works. And then can we plot some points? Yeah, we can plot points. Fun stuff right there. Beautiful. Do you have to draw the line? I don't have to. It's a scatter plot. You don't have to draw lines. I've noticed that students are very much like, if they see points, I want to connect them. They're like, I got to connect those things. Okay, it's not a dot to dot. You've always been taught to. All right, but questions, though, on how to kind of just organize some data? You've done probably most of that already. All right, so next part we're talking about is your domain and range. You should have heard these words before. Thank you. Do you guys remember what domain and range? That's a different kind of range. Anybody? Domain, range? Cole's head's going to explode. Domain is your inputs or your X values. You've probably learned that as domain is X. That's probably what you've always learned. Yeah, your domain are your X values. All right, so we talked about X values. Those are also your inputs. Those are those numbers you're plugging into the machine. All right, so your X values are the ordered pair. I bet you can tell me the definition for range now. Yeah, or also known as your, yeah. Range is your output or your Y values of your ordered pairs. One thing I see students do a lot is they mix up which one's X, Y, domain, range, which one goes with which. The easiest way for me to remember this, if you look at domain, starts with the letter D, range starts with the letter R. Alphabetically, domain comes before range, and X comes before Y. Yeah. To me, that always helped me remember it when I was younger. Think about alphabetically. Domain comes before range, so X comes before Y. That's right. Look at that. We just talked about some English. All right, so if you think back to your temperature problem that we just did, which is the domain and range? So which numbers were domain? Good, the months. So 1, 2, 3, 4. Good. Range was your temperatures. What were they? 6. Thank you. Domain and range, we always list these again from least to greatest. I know, kind of throws you sometimes. The clicking from the Chromebooks. I don't know why it does that. All right, so if we look then at this next one, what are the domain and range from that set of numbers? All right, so again, they need to be in order from least to greatest. So your domain. The domains are in order. Yeah, -3, 0, 2. Good. Yeah, your domains actually, in this example, they're actually in order already. So, but your domain are all your x values. And then your range.
Now these aren't in order. You got to put these 0, 7, 14.
They weren't in left to right order, but they were actually in order. Yeah, from right to left, they were in order. Main idea, though, make sure you write them in order from least to greatest. Domain is x, range is y. I'm hoping at some point in your math careers you've seen that before. What? Range could also be if you're talking about like mean, median, mode, and range. Then it's your highest minus your lowest. That would be your range. Yeah, different type of range. Really? You've never heard of domain range like this before? Really? That's surprising. Is it, I would have thought so. Are you okay, though? Domain is x, range is y. Okay. As long as we're good. No worries. All right, so let's kind of put this whole relations, like how to organize data, all this stuff, put that together with functions and tell how can you determine if it's a function or not. Okay? So we talked about functions a little bit. Actual definition of a function, just so you have that in front of you. It's a relation, so any type of, like, it could be ordered pairs, it could be a table, it could be a mapping diagram, it could be a graph, in which each element of the domain, each x, corresponds with exactly one element of the range, with one y. So in other words, if I put in a 4 and it gives me an 8, the next time I plug in a 4, I should get an 8, right? So you're looking for that x value that was repeated, and it shows something different. If you don't see an x repeated, then I have no idea. Like, as far as I know, it's fine. You know what I mean? So I'm kind of looking at, as far as you can tell, is it a function? So part A, is this a function? Yes, this is going to be a function, right? Because my x is never repeated. So as far as I can see, they only went to one thing. It's fine. So this is a function. What about B? Why not? Yeah, look here and here. I plugged in a 4, it gave me a -1. I plugged in a 4, it gave me a 1. Yeah. So the fact that your y value repeated doesn't matter. Did you ask me? I'm sorry, I didn't hear you. If you did. So this is not a function, but it's because of this 4. Right? You have to look for the x's that repeat, and then gives you something else. That's what makes it no good. Okay, because of this 2. Yep. See, I plugged in a 2, it gave me a -3. I plugged in a 2 again, and it gave me a 3. No. That machine's broken. What about D? Yeah, it's fine. Look at your x's. -7, 9, 14, 7. They never repeated. If your x's don't repeat, that's fine. As far as I can tell, it's good. Ordered pairs don't have to be listed in order. Yeah. Domain and range and the mapping diagrams should be in order. All right. If you're looking at a graph, right, that's the fourth way to organize our data, we can use what's called the vertical line test. Okay? Vertical line test means that if it touches more than once, kind of like if I see that x repeated and it gave me 2 different things, if it hits it more than once, it's not a function. Because if I look here, if I would think about right here where it hit and it hit again here, just to kind of illustrate how this is working. If I think about what the ordered pairs are, this you could say is maybe at 1, -1, where this looks like 1, 1. Look at your x values. Yeah, I mean you've plugged the number in twice and gotten 2 different things back. So if it hits it more than once, not a function. No, not a function. No go. What about B? Yeah, this is good. All right, if I place a straight line through, it only hits it once, so I'm good. What about C? Sometimes it's hard to see. There's one right here, and it hit again here. Yeah, sorry, sometimes it's hard to see the way it printed on there. How about A down here? Why not? It's a circle. If I put a line through it, it's going to hit twice. No. B? Yeah, this one's fine. They're kind of close, some straight lines, but they never actually hit more than once. Perfectly straight line. This one? Yeah, this is fine. Notice it's called the vertical line test, not the horizontal line test. We do use a horizontal line test for other things like pre-calc, calculus, but we're not going to talk about it in here. Yeah, we'll keep that out of the conversation today. All right, so what we're going to do next is I'm going to give you guys 3 minutes at your table groups. I'm going to give you a stack of cards. I want you to organize them for me into yes, these are functions, and no, these are not. All right, so here we go. We're going to go through each one. Check your piles as we go through them up here, okay? All right, so here we go. This one here, yes or no? This is a yes. This is a function. Look at your x values. Did they ever repeat? They didn't ever repeat, so it's fine. As far as I can tell, it's good. Here was the tricky one that I threw in there. How many of you said yes, that's a function? One group? Yeah, you guys said yes? You guys said yes? You guys said no? This is a function. All right, hold on. But everyone's like, whoa, whoa, whoa. Time out, guys, time out. The reason being, do you see how some of those circles are colored in and some are open? If you think back, Algebra 1, remember you used to have to graph like the less than, greater than, had the open circle, closed circles. The open circle means it's not actually including that number. That was a tricky one. I said it was a tricky one. I won't actually put that on a test. I'm just curious to see what you guys do with it. Ooh. I made it terrible. I felt weird. Yes or no? No. You got 27 repeated and it's giving you wrong answers. All right. How about this one? Yeah. Your x values, they didn't repeat, so we're good. Guys. Hey. Stop it. Yes or no? Yes. Look at your x values. This is fine. The fact that they all went to -4, I don't care about that. I'm looking at these never repeated, so I'm fine. We're good. Yes or no? Yes. Yep. Yes or no? The 6. Yeah, that 6 repeated. No good. Yes or no? Yep. Look at your x values. We're good. Yes or no? Why not? Yeah, that 9. I put in a 9, I got a 2. I put in a 9, I got a 5. Not good. No, we just looked at a circle. Yeah, look at your x's. They didn't repeat. I'm fine. No, fails that test miserably. Yes? Yeah, my x's didn't repeat. Yep. Yeah, if you look at your x's, they didn't repeat. So the easiest way to check to see how you guys did is look at your no pile. You should have 1, 2, 3, 4, 5. That tricky one usually throws people. Look at your no pile, see how we did. All right, go ahead and compile your cards back together. Put the rubber band around them. I'll collect them from you in a little bit. Yeah, you can shuffle them if you like. All right, the last part of this today, we actually are going to do a little math. But again, it's basic. This is really more, can you actually handle the terminology more so than the actual math, okay? And what this is called function notation. It is just another way to write something. Okay, like instead of me calling him Sam, I'm going to rename him George. Okay? It's just a name for something. I'll collect them in a minute. Thanks. So normally we're used to seeing like y equals 3x plus 2, right? We've seen stuff like this before. But instead of it written this way, I might rewrite it like this. Take a look at what changed. It went from a y to an f of x is how that's read. Guys, I need you to pay attention here. That f parentheses with an x in it, that's read f of x. Okay? That is called function notation. The f is not a variable. It is his name. It's like Frank. Okay? It is his name. Do not solve that for f. Oh, I have students who try that all the time. F is not a variable. Okay? And then if you look, what we're doing, if I had asked you to like evaluate, if x equals 1, you tell me what you get. We can do that, right? If I asked you here, plugging in x is 1, you'd be like, all right, 3 times 1 is 3, plus 2 is 5. That's big deal. I can plug a number in and see what I get. It's the same idea over here, except this is just another way to kind of organize your work, right? So f of 1, it's all it's saying is I'm going into the equation that has an f, I'm plugging in a 1 in place of the x. See how the 1's in place of the x? So this part here is just labels. This is all this is. It's a label. It is not for you to solve. Understand? Not solving for f. You're not moving the number that's in the parentheses. It's just a label. So then I'm plugging in a 1. 3 times 1 is 3, plus 2 is 5. You're just plugging stuff in. Okay? And then we talk a little bit about independent and dependent variables. The independent variable is x. The dependent variable is y. It depends on what value I plug in. All right. So the easiest, like for independent and dependent, to me, it's just story problems are the easiest to figure those out. Like if I would say, you know, I have cost and I have like concert tickets. Which is depending on the other? The cost depends upon how many concert tickets you buy, right? If I buy 5 tickets, it's one cost. If I buy 12 tickets, it's a different cost. So the cost depends on the concert tickets. Yeah. So to me, yes, I know. But that's like story problems are the easiest to kind of figure those out. Which one depends on the other one? So for f of x equals negative 4x plus 1. Again, that f of x is just a label. It's just a name for him. What is the output for the given input? Write your answers as an ordered pair. Use your proper notation. So again, this is just us practicing function notation. So see how this is f? So I'm going to say f of negative 2. So this is me showing my work, right? Again, this is just a label saying I'm going to the equation that has an f for its name. I'm plugging in negative 2. Let's see what we get, right? So I'm going to do negative 4, parenthesis negative 2, plus 1. I'm just plugging in for the x. That's all I'm doing. So what is negative 4 times negative 2 plus 1? That's 9. So as an ordered pair, what number did you plug in? And what number did you get out? There we go. It's not that it's overly hard, it's just different terminology than we're used to hearing. Yeah. Yes. Yep, I'm giving you the domain, you're going to find the range. Giving you the x, you're going to find the y. Okay, so if we look at the next one, part B, again, labeling my work, I'm going to the equation that's labeled f. I'm going to plug in, it asks me to plug in a 0. Right? Those are just labels. That's all that is. It's labeling my work. So I'm going to the equation f. I'm going to plug in a 0. All right? So we have negative 4 times 0 plus 1 as 1. So to write my answer as an ordered pair, like the directions asked, right? What did you plug in? What did you get out? 1. Yeah, math-wise, not hard. Just the terminology here. And then the last one, I'm going to go to the equation f. I'm going to plug in a 5, right? If you look at part C, it's asking for a 5. All right, so go to equation f. Negative 4 times 5 plus 1 is negative 19. Yes, this is you labeling which equation you went in. Because you could have like equation f, g, h, j, like you could have a bunch of different equations. And I could ask you to plug in different numbers into different equations. So you'd be kind of like, hey, I went to this equation, I plugged in this number. This is what I did. So what did you plug in? And what did you get out? Okay. So down here it says use proper notation. I'm looking for you to actually use the proper labels on the outsides. That's what we're practicing. Do I think I could ask you to do this and not use proper notation? Yeah, I know you guys could plug in a number and get an answer back. All right, we can do that. All right, and story problem. Tickets to a concert are available online for $35 each, plus a handling fee of $2.50. The total cost is a function of the number of tickets bought. What function rule models the cost of the concert tickets? Name the independent and dependent variables and evaluate the function for 4 tickets. Whew, there's a lot going on. Most students, if I gave this to you, you would only answer the very last sentence. Most of you would just tell me the cost for 4 tickets. I have no doubt in my mind you can do that. That's not hard. But we're trying to do all the different parts of this. Okay? So let's kind of talk about some of this in here. If it's asking for you to write a function rule, it's asking you to write an equation. That's what it wants. And a lot of you will skip that step even though I know you know what the equation is because you could tell me the answer. So now the whole f of x, some of you will like to use that terminology f of x and not ever want to change from that. Me, I try to use it so it's useful. So me, I would probably use c of t. Why? Cost of tickets. What's your cost of your tickets? Yeah. To me, it makes sense, right? That's a label. Label it for what you know it to be. All right, so cost of tickets is what? How do you find the cost of the tickets? Make sure you use the same variable. Yeah. Don't skip that step. That shouldn't be a hard step for most of you. You know how to do this. It just wants, that's the first part it asks for. What function rule or what equation models the cost? There it is. No matter how many tickets I want, I could always plug it into here and find out how much it's going to cost me. Name the independent and dependent variables. All right, so independent and dependent, which one depends on the other? The cost depends on the tickets, right? So the cost is what depends on the tickets. Depending on how many tickets I have, that cost will change. But it's easier to think about it when you just kind of say it in words. The cost depends on the tickets. All right, and then evaluate for 4 tickets. So if I'm using my actual notation and my labels, the cost of 4 tickets, right, actually using this label appropriately, I'll just go ahead, 35 times 4 plus 250, and what do we get? $142.50. Now my directions do not say to actually use an ordered pair, so I can go ahead and leave my answer that way.